Hi! Today we're going to learn about partial fractions. Let's say we have to solve the integral of 1 over 3x squared plus 18x plus 27 dx. So let's rewrite this as 1/3 the integral of 1 over x squared plus 6x plus 9 dx, which would be equal to 1/3 times the integral of 1 over, let's move this over a bit so we get more space later on, which would be equal to 1/3 the integral of 1 over x plus 3 times x plus 3. So now let's just take this integrand here, 1 over x plus 3 times x plus 3, and let's say that we want to break this into two parts. How would we break this into two parts? Well, we know that we could break the numerator into two parts, however here we only have one term, so we can't do that here. And we don't know how to break the denominator. So in this video we're going to learn about partial fractions decomposition, which is a way of breaking the fraction into two parts by splitting the denominator. So this would be equal to a over x plus 3 plus b over x plus 3. And one thing to keep in mind is that the degree of the denominator should always be 1 greater than the degree of the numerator when you write out the form. If this was x squared plus 3, then you would have a plus ax plus b. So this way, the denominator would be 1 degree greater than the numerator. And you always have to write out the full form. If this was x cubed plus, or x to the 4th plus 3, this would be ax cubed plus bx squared plus cx plus d. So you always have to write out the full expanded form. In this case, it's only x plus 3. So that means that the numerator would only be a times x to the 0 power, which is just a. So, now what do we do? Well, now let's multiply all of the terms by this denominator here. So that way we get 1 is equal to a times x plus 3 times plus b times x plus 3. Because we know that when we multiply this denominator by this term here, the x plus 3 and x plus 3 will cancel out, and same for the b, or for the second fraction. So, this would be equal to ax plus 3a plus bx plus 3b, which is equal to 1. So now let's, instead of writing 1, just 1, let's write 1 plus 0x, because we have some terms over on the right side which are in terms of x. So now let's group these. We get x times a plus b plus 1, this is the constant side, times 3a plus 3b is equal to 1 plus 0x. So if we have 0x, and 0 is a coefficient of x here, that means on this side 0 must be the coefficient of x. So that means that a plus b is equal to 0. Here we have 1 times some value is equal to 1. So that means that this value has to be equal to 1. So we get 3a plus 3b is equal to 1. 3a plus 3b is equal to 1. So over here, this would mean that a is equal to negative b. If we plug that into this system of equation, we would get negative 3b plus 3b is equal to 1. However, we know that that's not true. We know that negative 3b plus 3b cannot be equal to 1. It must be equal to 0. So where did we go wrong? So let's go back over our work. So we did this part right, and we did this part right. Did we group it right? Yep, we grouped it right? And now we created our systems of equations correctly also. So where did we go wrong? Well, maybe we didn't go wrong. If this isn't equal to the value that we were looking for, then that means that you cannot split it up into two different fractions. So that means that in this case, you would have to compute it using some other method. But in this video, we only went over partial fractions. So we're just going to say that we cannot compute it. I should say cannot compute using partial fractions, PF. But you may be able to compute it using some other method. So, today we learned about partial fractions and its limitations. Thank you for watching this video.